Hey guys, welcome. This is our review video. So we're going to go ahead and take a look at some of these problems and talk about them and explain them. Our first one, we're looking at this picture over here to the right. And in this picture we have multiple planes. And so we're going to determine if these questions are true or false. Number one, ADF are coplanar. Remember, coplanar means points are on the same plane. So we have our 3 points ADF. And what we want to say is, are they on the same plane? In fact, they are. They're on the back plane. So we're going to say that this is true. Number two, AC and FE are coplanar. So these lines are on the same plane. AC right here and FE back here are clearly not on the same plane. Okay, so we can go ahead and say that's not going to be true, so that's false. Number three, ABE. A, B, and E are on the same front plane, so that is true. D, A, B, E are all right here on the front plane, so that is also going to be true. AC are collinear. Collinear, that's spelled wrong, should be 2 L's. But collinear basically means that we have points on the same line. AC are definitely on the same line here, so this is true. D, E, B are collinear. D, E, and B are not all on the same line. There's 2 separate lines. So this is not true. False. Okay? Alright, moving down. Okay, so the next couple questions refer to this picture. So we're going to go ahead and draw some things into this picture to make it a little easier. BC is 12 and CE is 15. Then what is BE? Well, if BC is 12 and CE is 15, then the whole segment is going to be 12 plus 15. So we're going to add the 2 together. So we're going to basically get 12 plus 15, and we're going to get the answer of 27. So we'll get 27 is the measure of our segment. Blank is the angle bisector of blank. Okay, our keyword is bisector. It means it cuts something into congruent pieces, and it's an angle. So we have to look for congruent angles. And I see congruent angles in BCG and GCA. Since those angles are congruent, I know the bisector has to be the segment in between, which is going to be GC. So we're going to go ahead and say GC. So it's kind of small to write in this box, so I'm going to go ahead and try and squeeze it in. But that's a segment, so we're going to put a line over it. So GC is the angle bisector of, the angle is going to be BCA. So angle BCA. So GC is bisecting BCA. Alright, number 9. We have BC and CD. Notice BC and CD are congruent segments. So all I have to do is set these equal to each other. So I'm going to go ahead and I have some scratch paper with me, and we'll go ahead and write this out. They're congruent to each other in the picture, so that means I can set them equal to each other when I'm doing my algebra. So we get 3x plus 2 equals 5x minus 10. Always move the variable first. Okay. Then we'll go ahead and get the variable alone. And that leaves us with x equals 6. And it said solve for x here, so this is our final answer. And we'll just write x equals 6 and put that in a box. Okay, so again, we know that they were equal to each other because the segments are congruent. Alright, number 10, AC and CF. Again, AC and CF are congruent segments. So we can go ahead and use that knowledge to set them equal to each other. So 5x minus 16 is equal to 2x minus 4. Go ahead and move the smaller variable. Then we'll move everything away from the variable. And x equals 4. Now, my answer is not what x is, I want to know what AF is. Okay? Well, first, if I find AC, then I could double it to find AF. So AC is equal to 5 times 4 minus 16. That's going to be 20 minus 16. So AC is going to equal 4. Well, AC is congruent to CF. So CF is also 4. So the whole segment, if we add them together, we should get 8. So AF segment should equal 8. Okay. Number 11. BCG equals 60, and what is GCA? Well, if we look at BCG, we can write 60 degrees in here. And then GCA is right next to it and is congruent to it, so it has to be 60 degrees as well. So I'm just going to write 60 in there. And then it asks me, what is BCA? So BCA, and we're going to add those together and make 120 degrees. So 60 plus 60. All right, number 12 is our last problem from this picture. And it says ACD, and I'm going to redraw this picture so we can see it a little bit better. But we're going to move it up a little bit so we're not going to see the picture anymore. So I'm going to draw the angle. Here's ACD is 60, so from here to here is 60 degrees. And then there's a line that's kind of coming through this here at H. And it says DCH is going to be 20 degrees. What is HCA? So what's this X? Okay. And so what we've set up here is we've actually set up an angle addition postulate. So if I do 20 plus X, I should equal 60. So I just got to subtract 20, and X equals 40, which is the measure of HCA. 40 degrees. Okay? Alright, so we got through 12. Now we're going to take a look at 13. So in this picture, we have two angles. Now it doesn't say the word bisect, so I don't know if they're equal to each other, so I don't want to do that. But it does tell me PQR, so PQR, so that's the large angle here, is equal to 4x plus 47. Okay? So when I set up an equation here, what I want to do is I want to go ahead and just say, hey, look it. Little angle plus little angle should equal the full angle. So that's what we'll do algebraically. So here we have two little angles set equal to the large angle. And we can go ahead and do some combining like terms. Move some things. And we get x equals 5. So just doing our basic algebra here, we get x equals 5. Now it wants us to find PQS, so PQS is right in here. Okay, so we have x equals 5. Pause the video if you need to write that down. But then we're going to go ahead and just plug in 5. So this is 35, and we get 31. So the measure of PQS turns out to be 31 once we solve that we got x. Okay? Alright, this next one, we're going to go ahead and again have to draw a nice picture. We know that they're collinear. That means we have 3 points on the same line. So I have a line, and we're going to get A, B, and C, and B is going to be between A and C. So I know A and C have to be my endpoints. B is somewhere in the middle. Now, it doesn't say it's in the exact middle, so I never put it in the exact middle and make it look like it's not in the middle so I don't trick my eyes. So I purposely move it to one side when I say between, because I don't know if it's actually immediately in between. Now I'm going to label my pieces. So I got my AB and my BC, and then AC is the whole segment, so I always kind of like to write it like that. Alright, now looking at this picture here, we can go ahead and find all these segments, but what I have to do is I have to go ahead and set up an equation first. Again, AB is not going to be equal to BC here, but I do know that little piece should equal the full piece. Okay, so let's go ahead and write that equation. Again, little piece should equal full piece. So combine like terms. We get x equals 2. Again, that's not my final answer. What I want to go ahead and do here now is I want to go ahead and take that 2, plug it back into my other answers. So AB, I'm going to plug in 2 to this equation. That's going to be 8 minus 1, so I get 7 equals AB. Move that up. Okay. Then BC, it's going to be 4 plus 1 or 5. And then the whole segment is going to be the combination of those two. So 7 plus 5, which is going to give me 13. I'm sorry, not 13. Blah, 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 blah. 12. Okay? Alright. Let's see if we can get one more in this video, then we're going to have to do a second video. Okay? Oh, wait. We might get a couple of these in here because these ones are pretty easy. Alright, so supplementary to NQX. So, NQK. So this is our full angle here. Supplementary means I need to add to 180 or create a straight line. So if I actually add KQP, that would work. KQP. Okay. Vertical to PQM. PQM is right here. So the vertical angle is actually going to be NQL. Congruent to NQJ. So NQJ is actually a vertical angle to KQP, and we know vertical angles are congruent, so this angle should be congruent to that angle. Adjacent and congruent to JQM. JQM is vertical to this 90, so we know this is 90. And then we also know that MQK plus JQM should make 180, so this has to be 90 over here. So KQM. And number 19, we're going to get complementary to KQP. KQP, we know that this whole thing makes a 90, so it's got to be PQM. Okay. So those are kind of tricky problems there to do. So we'll go ahead and pause the video here and we'll pick up the last 5 on the next video.